I now want to introduce Alette de Wit, who's going to provide a summary of some of the work that she's been doing within the South African government and in collaboration with Dr. Jack down here, Dr. Jack Radcliffe from University of Manchester. I think I'm really pleased to be collaborating with these two. I think they're doing an amazing job in leading discussions and initiatives within governments and universities around geodesy and trying to grow capacity. So please put your listening ears on, and I encourage you to see if we can all learn some lessons from the great work that Alette and Jack have been doing recently. So over to you. Thank you very much. Just when I go and talk you up. Okay, so after this, she's going to go and get an optometrist check. But apart from that, Alette, she's on the ball. Over to you. Thank you.
Oh, okay. Thanks so much, Nick. Now they can all hear me. Yes, thanks for the introduction. So this is, I mean, I have myself and Jack there listed as authors for this presentation, but there's really a lot of people, some in this room who's contributed a lot to the work and some of the initiatives I'll talk about today, and also a lot of people that's not here with us today. And I have to warn you, I don't work on GNSS. I'm not part of the IGS. I'm a VLBI person, so there will be telescopes in these slides. So yes, I'll be talking about charting the course for GGOS Africa. So we're looking at a GGOS Africa, which will be an affiliate of GGOS, and basically integrating Pan-African geodetic efforts for global impact. Okay, so the question, I guess, is do we need a GGOS Africa? And I mean, often, and when I give this presentation, I think people, you know, most people, I think, across the world often see Africa as only a beneficiary of global science efforts. And but we've listened to a lot of talks since Monday, and we know that there's a lack of, well, capacity, but also infrastructure when it comes to geodesy in Africa. And we all need to work together, you know, to contribute to global geodesy. But do we need a GGOS Africa? And that's what I will be talking about today. And the answer is absolutely yes, we do, because I think it's time for Africa. And if we can all work together, it would be fantastic, and we can make this work. It's really time for Africa. And something like a GGOS Africa that can coordinate efforts among, you know, all the countries in Africa is something, in my opinion, that will bring us all together and help us to achieve these goals. So you've seen this. I couldn't take it out. I have to show it again. So don't know how much more I can say about this. You know that these are all the techniques, all the stations that contributed to ITRF 2020, all the sites, including VLBI, SLR, GNSS, and DORIS. And I mean, it, like all the, well, all the other speakers, it's basically the two of you have said in your presentations, we can clearly see that there's a lack of infrastructure in Africa. The situation is not that bad when it comes to GNSS, but for the other techniques, well, the situation is not that good. I'm just waiting for it to come up. If we look at core or fundamental stations for geodesy, and those are stations that have all four techniques on the same side, there's only one such station on the entire African continent. And of course, these stations, fundamental stations, are absolutely crucial to achieve that millimeter precision, I think, that Nick or Ryan mentioned earlier today. So that station is in South Africa. It's called the Hartebeespoort site. It has 3 VLBI telescopes that participate in geodesy. It has GNSS. You can see there in the front of the picture. And then there on the right-hand side, the white buildings are 2 SLRs. We also have a lunar laser ranger, and then the Doris is further up the hill. So it's not shown there in the picture, but again, the only fundamental station on the entire African continent. And this has not been mentioned, the ICRF, the Celestial Reference Frame. But this is a very important component of Geodesy as well, of IAG, of GGOS, is our celestial reference frame. And we can only get a celestial reference frame using our VLBI telescopes, none of the other techniques. So this frame only depends on only one technique. And here I'm showing the 167 telescopes that participated in observations for the current realization of the celestial reference frame, the ICRF3. And again, you can see only one side on the entire African continent. So while the ITRF, I think, is not doing too bad, you could use more stations. When it comes to the ICRF, and of course, geodesy depends on the ICRF very much, we need a lot of help. We need more stations in Africa, but Nick also, the deep south, we need some work there in Australia as well. Okay, so I think after all the talks and showing you this, we are all pretty clear on, there's a lack of geodetic infrastructure in Africa. Why do we care? Why do we need more infrastructure in Africa? And I'm not going to go through this in detail because I think it's been covered by Aslam and Nick and Ryan, since Monday, but it's actually twofold. So the global geodesy supply chain needs Africa. That's the first thing. Yes, Africa, they need us, okay? Africa, the continent's a big landmass. It's strategically located. And so the supply chain needs that geographic coverage, balancing global ground station distribution and improving accuracy. But also unique geophysical data. Africa's diverse landscape provides critical environmental and geophysical data, and improving things like global models, okay, for global satellite systems, Earth observations, climate models. But on the other hand, Africa also needs its own geodetic data. And again, there were wonderful examples during previous talks, things like climate change, measuring sea level rise, environmental monitoring, disaster response, navigation, surveying, mapping, infrastructure development, urban planning, sustainable development, overall economic growth. So this is really important that we look at Africa, and especially how can we improve the situation and get more infrastructure on the African continent. So to really look at what is the issues we're dealing with in Africa, we decided to have this day-long session at the United Nations Science Summit, September last year. And this was really to take geodesy to the Science Summit. I don't think geodesy was ever a topic at the UN Science Summit. So this was the first time, but also to specifically talk about Africa. So the session was called Africa Rising, Shaping Our Common Future Through Geodesy. And I have to thank many of the colleagues in this room that participated in this. Fernand, next to me, Nick was part of it, Rachel. There she, Aslam was there. So yeah, wonderful day we had there, wonderful discussions, and thanks again to everyone who participated in this. So what was the outcome of these discussions? And I mean, it's much more than just a lack of infrastructure in Africa. Yes, so the first one, that came out of these discussions in terms of challenges is, yes, lack of geodetic infrastructure, but it's not just the lack, it's also infrastructure ownership, okay? Often private, companies owning these equipment. Outdated equipment is another one, inadequate monitoring stations. We talked a lot in previous discussions this week about access to data or even outdated geodetic data, so the availability, the quality, data management, outdated surveys was a topic that came up a lot in our discussions around Africa and geodesy. But also, and we all know this, I'm just repeating what we've already heard and what we already know, funding and resource constraints, limited funding, resource shortages, and prioritization. What does your government prioritize? Is it geodesy? Probably no. Capacity building and training needs, that was also a topic of discussion, you know, shortage of skilled professionals, limited training opportunities, knowledge gaps, and so on and so on and so on. Okay, but the most important thing that came out of this session at the United Nations Science Summit was the need for collaboration and partnerships among African countries. We need to coordinate our efforts, and this is the biggest problem, at least I think, that we're facing in Africa in terms of geodesy. And AFREF is a very good example of how we do not work together. Okay. So this brings us back to, do we need a GGOS Africa? And hopefully I've convinced you, yes, we do need a GGOS Africa. We do need to coordinate efforts. So what's the progress to date on GGOS Africa? So the first step was to identify the need, you know, the need for a Pan-African institute or organization for geodesy to coordinate efforts. We've done that, okay? We've talked about it. We know there's a need. Of course, it's easy to say that, you know, let's talk about Africa if we have not addressed things in our own country. So we started with South Africa, and things are, you know, very fragmented when it comes to geodesy in South Africa. We have the space geodesy site that falls under astronomy. There's Aslam's department that, you know, does the mapping. We have our space agency, and then the universities, and none of those people, we realize, are talking to each other. I mean, now I'm talking to Aslam, you know, and we even brought an astronomer along. So things have been improving since then, but it was different a while back, okay? So we are in the process to establish a geodesy committee in South Africa that would be led by my department, Department of Science, Technology and Innovation in South Africa, and this is in progress. We had discussions, we had meetings, and hopefully we'll establish this committee soon. So now I've already basically said what I wanted before I even came to this slide, but those are the institutions involved and under which government department they fall. So there's Aslam's department, NGI, you know, the mapping organization in South Africa. I mentioned our space agency, and then, of course, under astronomy, our radio astronomy observatory that runs our space geodesy program. So now all of those people are talking, and we're working on a working group, establishing a working group for South Africa. Also, as part of that, and yeah, now I need my glasses to read this, but never mind, I'll try. I cannot read that far, and I can also not see this. Any case, so from the department side, we have a program on astronomy that I'm part of, but space geodesy falls under astronomy, thank you, in South Africa, but it was never formally recognized as a program in government. So the first step for me, and probably you can also not read there, but now I can at least read for you, was to submit a document to ask that EXCO approve that geodesy formally becomes a program within government. And again, you know, I have to thank people like Nick for their support. On the right-hand side, there's all the letters that I received from, you know, the GGCE, the IAG, GGOS, that we submitted as part of this. And basically what we asked for is we want to establish this working group in South Africa. We want to sign your multilateral MOU, okay? But also we want to develop a national geodesy coordination framework within South Africa, and we hope eventually also a strategy for geodesy within South Africa. We want to secure long-term funding, human capital development, of course, is very important. And then the last one, we want to take the lead in the establishment of GGOS Africa. Okay. And this was approved, so it's official. We can clap. Hey, wow, you know, things are happening. So yes, in any case, now I have to take this off again. So in terms of the implementation of GGOS Africa, this is officially part of the GGOS implementation plan. I'm on the GGOS governing board, luckily, so I could sneak this in. But GGOS Africa is part of the GGOS implementation plan, and according to that plan, we're supposed to establish GGOS Africa by the end of this year. So I need all of your support. We need to do this. Then in terms of some key events, okay, so I've already talked about the Science Summit. This was one of the first steps for Africa and towards, a GGOS Africa. And then also this year we had a Geodesy session at the African Astronomical Society conference that was in Johannesburg in South Africa. So yes, this is the African Astronomical Society, but I told you I'm from the VLBI side, so I work with telescopes, so, astronomy, geodesy, telescope, all the same thing. I think it's really important that we connect more with the astronomers, and I'll give more examples later. And this is also a platform. They have the funding, they have a conference once a year, and to have a Geodesy Day as part of this conference, to me seems like a good next step for us for GGOS Africa. And where is my colleague? He's hiding there from Botswana. The next AFAS meeting will actually be in Botswana next year, and we will have another Geodesy session. So if you want to meet more astronomers apart from Jack and, join us at this conference in Botswana, please look out for this. Alrighty, and then about collaboration and lessons learned. So I always think that, don't start from scratch. Learn from others' mistakes or from what they did right. And one such an example is the SKA project. So maybe you don't know, maybe some of you know, we are building the Square Kilometre Array, which will be the most sensitive, biggest telescope in the world, is being built in South Africa. And some of the outer stations will go into Africa. So this project has spent a lot of money on building capacity in some of the African countries for astronomy. And it's a big project. So there's a lot we can learn from them. And we have a lot of connections with astronomy. Again, like I said before, we use the same radio telescopes, but also we provide crucial data to the astronomers for their observations to be successful. They need EOP station positions, source coordinates, the celestial reference frame. All those things are also essential to them. Okay, so in terms of this project and capacity development in Africa, there's the SKA partner countries in Africa, and I don't know if you can read there, but it's Namibia, Botswana, Zambia, Mozambique, Kenya, Madagascar, Mauritius, and Ghana. And we've been doing a lot of work in terms of astronomy capacity development in Africa and those countries. We're now at that stage where we're looking at broadening this and also going into some of the other countries in Africa. Since 2015, there's been this a training initiative. It's funded by, partly by South Africa and by the UK. And because I'm involved, I made pretty sure that those students from these countries coming for training, and usually it's 4 weeks of intense training they do, that at least half of the training they get is geodesy. So we have been training students in geodesy. Okay, maybe mostly on VLBI, ICRF things, but still, they've received training in geodesy and not just astronomy. Our Center for High Performance Computing have been rolling out compute infrastructure in many countries in Africa, not just the partner countries, and I've actually listed them here. So apart from those that's there, it's also Zimbabwe, Tunisia, Sudan, Nigeria, Mali, and so on. And they are doing a lot of training on these systems in Africa, and we talked before about, centralized data systems. These things are available in Africa, and from our Center for High Performance Computing, I've heard that these resources are underused. So guys, these resources, we need this for geodesy. Let's make use of it. Yes, it was originally meant for astronomy, but it's sitting there and we can use it. Another initiative that came up recently that has some funding is co-location. So setting up observatories in these countries, building capacity, that's happened. what about co-location? And co-location in this project means, can we co-locate geodetic infrastructure with our radio telescopes at these sites? So that's what we're currently looking at, and of course training instruments. So there on the right hand side is an example of a training instrument, and I thought this was actually brilliant. This is not my idea, but when I saw it I was like, yes, this is what we need to roll out in Africa. It's called the TART telescope, the Transient Array Radio Telescope, and it's supposed to teach students in Africa about interferometry when you connect telescopes across different continents. But the receivers are off-the-shelf GPS receivers, so the students also learn about geodesy. So this is a very, I thought this was brilliant, dual-purpose training instrument. So that has been installed in Mauritius, Kenya, and Zambia up to now, but then also bigger activities. We converted a old telecommunications station in Ghana. It's now called the Ghana Radio Astronomy Observatory, a 32-meter radio telescope. There's a SKA type telescope coming to Botswana that is a collaboration with the Max Planck Institute in Germany. That is happening soon. And also there's plans for an African millimeter telescope coming to Namibia. And we've heard from colleagues in Nigeria that they're building a fundamental station, and there will be a VGOS telescope. So even in terms of telescopes, things have happened. And my dream is, can we use those telescopes and put receivers on those things that we can do geodesy with as well? And it's not just a dream. Between me and Jack, we've been having discussions with these people, and we're trying to see if that can actually happen. As part of this project, I said that we also rolling out some co-located instruments. So this and I. Where's the colleague from, where was it that talked about stations in remote areas, Ethiopia? Yeah, there he is, I can see. Okay, so this is the picture I wanted to show you that day. So our team at the observatory has built these systems. So it's basically the self-contained geodetic GNSS reference stations with full weather systems. It's weatherproof, solar powered, use cellular communication. You don't need any cables. You can literally take this and you can see the remote sites. There's just 3 sites I'm showing there, and put these things in a remote location. And it's been working very well. We've have a couple of them in South Africa now. And actually yesterday, my colleague phoned and said he's installing the 3rd one in Namibia. So if you're interested, there's some options for that as well. But then, of course, you need funding to do things like this, like a GGOS Africa and all of these things. We cannot just use the astronomers' funds all the time. We need our own funding as well. So myself and Jack and a bunch of other colleagues applied for funding, and it was approved in March 2025. So it's this UK Research and Innovation and Science and Technology Facilities Council. Oh, that's a long word. STFC, any case. Basically, they foster UK-African collaborations such as climate resilience, sustainable energy. And I mean, I can stop there. You can already see how geodesy fits into that. And basically partnering with Ghana, Kenya, Rwanda, South Africa, Tanzania, and Uganda. So we put in a proposal for seed funding for GGOS Africa. We got the funding. It's 2-year seed funding. And this project will run up till February 2027. And it's a collaboration between the institutes shown there. So Jack from Manchester University, Nick is involved from the GGCE. And of course, my department, Aslam is involved, Ghana, who else? Sorry, guys, I'm having trouble here. Ghana, Kenya, I should know this, Uganda. And then the story I want to actually tell you is that Tanzania is listed there, but we didn't know anybody from Tanzania, so they weren't in. I know, no, I know. Okay. So these were the original partners, but then end of last year, now I'm in government, so I'm lucky. I sit in all these bilateral meetings with your countries all the time. And we had this delegation from Tanzania visiting South Africa. And as I usually do, I talk a little bit about SKA and astronomy, and then I switch over to geodesy. And your Deputy Minister for Science and Technology in Tanzania listened for half an hour to me talk, and now he's inspired. He wants to do geodesy with South Africa. He phones us every week. So these things are possible. He didn't know the word geodesy, he didn't know what it was, and now he is just inspired. So it is possible to convince your governments, okay? These things happen, and now we will actually officially add Tanzania at some point to this project. And of course, in these types of meetings, we agree on programs going forward between two countries, and this gets signed off. And Geodesy now, in this bilateral agreement between South Africa and Tanzania is definitely high up in the list. So there's other stories like this as well, but these are the types of things, that can happen and that should be happening. And people always say, people in government they only care about the sexy science. Show them some beautiful pictures of, space and some galaxies, and everybody's inspired. It's not true. When that minister, yes, he forgot all about astronomy. So yes, our vision with this project, and I don't even know if I have enough time left, but I'm almost done. So is we intend to establish GGOS Africa to support both new and existing geodetic initiatives throughout Africa, to promote developments at global, regional, and national levels. But I want to be very clear about this. This is not a replacement for ongoing initiatives. We don't want to take over from AFREF or from what already exists in Africa. We just want to bring all of that together, and we want everybody to coordinate. So this is just a structure that will coordinate efforts. I'm not here to take over from any initiatives that you already have in place. I'm just saying, let's meet somewhere and, make this work. So in terms of the funding project, is some of our goals is assessing Africa's geodetic infrastructure and resources. And luckily, Nick is already doing the work for us because he's making you fill in all these forms. Or was it you, Ryan? So please share, because And Aslam has been doing some work in, in getting information about what is available in each of these countries. And hopefully with the funding we have, we can complete these surveys. Developing strategic infrastructure plans using simulations. A lot of simulations have been done on the VLBI side, and if you go and look at some of those papers, you will see that we need more telescopes on the African continent, and also more in the south, Nick. And then training early career African geodesists through workshops, collaborations, of course, officially establishing GGOS Africa to help coordinate geodetic activities, and then raising awareness among policymakers about the role of geodesy in sustainable development. So these are our goals. We have a website. It's still partially under construction, but please go and have a look. And oh yeah, I have this thing. And these are the 5 work packages we have. It's basically based on the goals that I just talked about. So we actively working on these, and work package 2, and I'm highlighting this one because we're working with Prof. Paul Bucky from the Technical University in Kenya. He's leading this work package on the assessment of geodetic infrastructure in Africa. So thank you, Kenya, for stepping up and being part of this and doing amazing work. And yes, then we'll just end by saying that together we can build a geodetic infrastructure that not only strengthens Africa's position globally, but also addresses the continent's unique challenges. Let's seize this opportunity and make GGOS Africa a reality, because Africa's future in geodesy is not just needed, it's essential. And that is where I will end. Thank you so much. Questions?
If this isn't good, I don't know what is. That's a very inspiring talk. Thank you very much, Alette. Yes, Joseph.
Hello. Okay. Please come here. Okay, I'm not touching it. Can you? Oh.
Check 1, 2. Yeah, it was good.
Okay. So that's it. What's the magic?
Yeah.
Check 1, 2. Oh, check 1, 2 is the magic. Yeah, thank you so much for this beautiful presentation. I was so excited when you started talking about GGOS. And I was smiling within my mind that, yes, we need GGOS in Africa. I remembered in 2011, we started with GGOS in Nigeria. As at that time, Mark Pellman was the chairman of the GGOS on communication. A call was made for countries that would like to be part of GGOS. And we in Nigeria, I was the one that did the write-up, and we submitted it. And the GGOS board gave us approval as a candidate site. A candidate site is a site that is ready for collaboration, and it's a site that is fit to host all space geodetic infrastructure. Because before then, we have the IGS station, and we were streaming data, live data to IGS data center in California. And because of the stability of the station in Nigeria, we are now giving that approval by GGOS as a GGOS site. And we still have that approval until now. It was on that basis that I developed a proposal. We are supposed to go into a collaboration with NASA on VLBI. It couldn't work with NASA due to some obvious reasons. And in that process, the Shanghai Astronomical Observatory approached us, and we are on it. So if given the chance, we'll tell you how far we have gone in our VLBI project. We've gone very fast. As I speak, work is still going on. Even yesterday, they sent me the photograph, pictures of work going on at the site. So GGOS is possible for us, and I'm so excited for us to be partners. We are working assiduously to be a space geodetic site. We are believing that before the year runs out, we would have been a core site for GGOS, because we already have the GNSS in place, we'll have the VLBI in place, we already have, even though our gravimeter is not the absolute type, but still we could use it. And I also want to say excitedly that we are already talking, I'm already discussing with my partners again on the possibility of us setting up SLR on the same site. So we agreed that if we are able to successfully complete the VLBI, it's a GGOS site, if we are able to successfully complete it, then we will begin the process of the satellite laser engine. Thank you.
Thank you. Yeah, I just also want to say this is a very brilliant presentation. However, I have two questions. Though part of it has been answered by Dr. Dudu, however, I will still need more clarification for my own education. And the first one is on the GGOS. What is exactly the difference between the GGOS and the VBLI that we have initially discussed earlier in this workshop? Because VABLI, SLR, Doris, I believe it's the same thing they were doing. So what is GGOS contributing? Or is GGOS kind of housing for VBLI, Doris, and stuff? So what is the difference between GGOS and all these other techniques that we have discussed? Number two, this question is just for curiosity's sake. Ever since I was in school, I've never bothered, but somebody came to me and asked how. I said, well, I've never bothered to. And the question is, how was the parameters for datum, how were they determined? Like the semi-major axis, the semi-minor axis, the flattening, scaling, because for each of the datum, you have to define all these parameters. So how are they measured initially? Where did we get those figures that we put in place? I've never asked, but I think for curiosity's sake, I will be glad to know. Thank you.
So I don't think it's a matter of comparing GGOS to what's the difference between GGOS and VLBI, okay? GGOS is a part of the IAG, so it's both. It both speaks to the observing system, the global geodetic observing system, but also the organization that makes sure that this happens. And there's the four main techniques, which is VLBI, Doris, GNSS, and SLR. Okay, so when we talk about it, GGOS Africa, it includes all of Geodesy for Africa. Yeah. Does that make sense? Yeah. So the second question, I'm not sure I completely followed, but I think you want to know how all the different techniques go into a final solution. And I think, yeah, maybe that's something we can discuss over lunch tomorrow, because that will take a long time too.
I understand your question. I just can't answer it within the next 5 minutes. So I think we need to store that one for now. And just to come back to what is GGOS versus the others, the way I like to think of it is think about vertical lines. And so that's VLBI, that's SLR, that's GNSS, and that's Doris. The aim with GGOS was to make, instead of having vertical connections, to have a horizontal one. So it's to connect all the techniques, because some of the products and the services, like the reference frame or earth orientation parameters, all the essential products rely on working across each other. So GGOS is meant to bring everything together. So having GGOS Africa, it's like doing that all together for Africa. That's the purpose. Like that, bring all those techniques together. Yeah, that's right. All right, well, happy to take one more question. I know we're pushing it. We'll still have plenty of time for Christopher's talk coming up next. We're going to move some other things in the agenda until tomorrow, because I think this is really valuable. So we've got one more. Sorry, I didn't see who was first over here. Okay, thank you. Thanks, Aslam.
Thank you for the wonderful presentation. What I'm having is an opinion. I think little has been said in the presentation about EO, Earth observation. Earth observation is very important in geodetic analysis and mapping. Thank you.
I can answer that by saying, no, we're not leaving that community out. And usually that's a space science community. We just had the African Space Agency that was formed, what was it, just 2 weeks ago? Yeah. So we are working very closely with the South African Space Agency and space agencies in many of the African countries. The one thing I've also found is that South Africa is a bit different. In most of the African countries, space science, geodesy, astronomy is very often very connected, and often the same people and the same department. So no, we're not leaving anybody behind in this. But thank you for the comment. It is important, yeah.
Sorry, excuse me. My second question, I would think maybe
you want to know the meaning of life now, right?
Sorry, just is to Wala if she would be glad to put my question on the parking lot so that I will not forget. Thank you.
Yeah, I think we need to stop here. I'm happy to we can talk more after, but I want to give time for Christopher's talk. But please, thanks again to Alette for such an inspiring talk. Thank you so much.